Okay. I think this is Mr. Isam's screen. Can you please stop sharing?
I will.
So hello everyone, good afternoon.
Good afternoon.
Good afternoon.
So welcome to our session today. I'll just be waiting for a minute for everyone else to join. Okay. So hello everyone, welcome to our session today. We're talking about the future of transportation, more specifically aviation. So I'm your moderator for today. My name is Hamda Al-Ali. I work for the Technology Transfer Department here at Sharjah Research Technology and Innovation Park. I'll be briefly talking about the park or giving a brief introduction for everyone who's joining. And then we'll have the speakers for today. So Sharjah RTI Park was established as the leadership who paved the way for innovation. Our chairman is His Highness Sheikh Dr. Sultan bin Mohammed Al Qasimi. We were established back in 2016, so we are very recent, but His Highness had a vision for over 20 years to invest annually in research and development, education, and innovation. So when we were founded, we were under the American University of Sharjah, which is one of the top 10 in the Arab world and top 300 universities globally. It's very enriching in the research and development area and the education. So here in Sharjah Research Technology Innovation Park, we are building the innovation ecosystem by supporting our partners to scale and grow. We are generating employment, catalyzing knowledge economy, and investing for the future. So in the technology transfer department, we work using the triple helix system or the triple helix integration by connecting the government sector with the business and the private sector and connecting it with the academia. We focus on 6 main pillars. They are the environmental technology and renewable energy, healthcare, tech and digitization, mobility, logistics and smart city. We have water technology as well, production, design and architecture. So far, we have anchored 6 deep tech pilot projects in 2019 alone. We have attracted over $100 million in investment in our ecosystem. We have over 100 companies registered under the park. As we are closely connected with the university city, we have access to 47,000 students from 22 universities with over 2,000 PhD holders. So this picture shows our global vision and a lot of our partners globally and regionally. This is an exercise we did with Catapult, where we benchmarked Sharjah against global cities in the world, against 9 cities. We did the exercise for markets and investments, interfirm activity, knowledge and R&D, skills and human capital, infrastructure and culture, also governance and policy. This is the Skyway, one of the biggest transportation projects which we have on land. It has 4 different transportation pods. The biggest one is 3 kilometers in length. It goes up to 160 kilometers per hour. So the final stage is under construction right now. If you visit the park, you will be able to see it. We also have Merlin Sustainable Technology. It's a 100% sustainable ecosystem. It has an aquaponics farm connected to a solar PV panels and wind turbines. It also has a water desalination unit for desalinating underground water and basically using it for irrigating the plants in the aquaponics farm. This is Civil Twin Renewable Middle East. It's a solar PV panels company for testing different values for solar PV panels. This is Nepta Health. It's a British company, a startup here at based in Sharjah RTI Park. It's a woman tech health application. So Soylab is one of the biggest makerspace here. It combines basically 3D printing for plastic, metal, and it has 6 different, you can say, labs, I guess, for electricity or electrical, for textiles, woodcutters, 3D printing, and so on. It has 2 floors dedicated for 3D printing, and we have a floor for Immensa as well, which are specialized for metal and plastic 3D printing as well. So this is our framework collaboration with American University of Sharjah. It focuses on 4 main objectives. So next I'll be showing you some examples of the research projects which we have the University of Sharjah. This is one of the biggest projects, you can say, because it's a with a local print, you can say. So this project started as a startup from American University of Sharjah. Also, it's 100% sustainable, so it uses the solar PV panels as the main source of energy. Another one is the conductive concrete project with the American University of Sharjah. We also have the exoskeleton, which is a disruptive technology for wearable robotics. So one of our global activations or global is we have Women in Technology Forum, which happened back in February last year. We also did one this year as well, but it was virtual. We launched the first advanced industry accelerator. It focused on 8 main pillars. We also had the MENA Innovation Technology Transfer Summit back in September as well. It was also virtual, but it was very successful. We had more than 50 speakers from 100 plus countries and more than 5,000 participants. And we're launching the second one again this year in September as well. So we also launched the Sharjah Angel Investors connection or network, which is to enable the startups to access the local investors here. So when we launched back in September, the first event was dedicated for 3D printing. It was called the 3D Printing Emerging Tech Exhibition. It lasted for 2 months. It showcased the capabilities of 3D printing as it has plastics, metal. We also had concrete as well. And we had different participations from students who 3D printed a lot of amazing pieces as well. So we have a lot of upcoming activities. We're launching the Smart City exhibition, the second exhibition to launch in our building. We are also launching the MENA Innovation Technology Transfer Summit as well in September. So yeah, thank you. Next, we have Mr. Isam Moursy. He is the ex-head of GE Aviation for Africa, and he is currently the CEO of Isam Consulting. It's a Sharjah RTI-based company. Mr. Isam has 30 years of experience in the field as the head of GE Aviation. He was responsible for driving the growth of the GE Aviation in Africa expanding the customer relationships and long-term public-private partnerships across the region. Mr. Isam, you have the mic.
Thank you very much, Hamda. I appreciate it. Good morning, good afternoon, everybody. My name is Isam Moursy. As Hamda just said, I spent 30 years at GE, worked in various businesses. Finally, the last 12 years were in aviation, and recently retired. And gracefully, the Sharjah RTI has accepted my concept of establish the consulting firm in the area of technical skills and helping airlines in their MROs, the maintenance and repair facilities. Today, I have basically tried to give you all an overview of where aviation is going, and try to throw some ideas about what is the latest technologies that airlines and airframe manufacturers and engine manufacturers are looking at. And I've seen some of the colleagues here is going to talk to you about a few of the things that we'll be pointing out during the presentation. But quickly, if we look at aviation basically started with the Wright brothers in 1903. Is not a very, very old industry. Boeing as a company was established in 1914, followed by GE. Rolls-Royce started also at the same time. Airbus started in the 70s. The first jet engine was invented in Germany in 1939. So you could imagine the disruptive technology that happened to the aviation when the jet engine was introduced. But it took about 15 years for the first commercial jet airliner, the Comet. If you, the old timers like myself remember, is the de Havilland British-built airplane that you see the picture here, was introduced into the market as the first jet airline in 1952. So it's less than 70 years old. The first Boeing 737 that we all used to travel on was introduced in 1967. And a few years later, the Airbus A300 was introduced. So you see here, just I wanted to show you that in a very short frame of time, a lot has happened in the aviation industry. And also at the same time, the move from normal propellers to turbochargers happened during the World War II, and then by the end of the war, it just kicked off. So it was a disruptive technology and moved the industry way forward. Now, if we look at a group of people have put a paper recently during one of the IATA conferences about what are the items that will affect the aviation future. And the first one was the emergence of the middle class in Africa and in Asia. We all saw what happened in China and the immense pressure it has put on the aviation industry to support the Chinese travel when China opened up to outside travel and established many industrial hubs that required a lot of interconnectivity. Data is a very important subject because today, of course, data is not democratized across the industry, and the emergence of the Googles, the Facebooks in the world has led to a major shift on who owns the data and how much data these companies own versus the airlines and the travel in the travel market. So if the world moves into sharing data, I think it will help a lot the aviation industry grow. If it becomes basically torn apart in islands, I think it will negatively affect. So a lot of people talk about the effect of data, who owns data, how you use data. Imagine with the COVID-19, for example, if the world is able to share data about who is vaccinated, who is not, and how does that affect travel? What would be the effect instead of where we are today? Security, of course, is a problem. The world has a lot of issues, and flying around the areas that has, let's say, conflicts versus flying into areas that restrict their airspace is a major issue, and of course the fear of terrorism and so on. So we need to see advances in that area too. Governments has a role to play. We see some governments are very supportive of the aviation industry, like the UAE government, for example. But a lot of other governments are very restrictive, and they put tariffs and so on the movement of goods. I mentioned the introduction of the jet engine, the turbo technology in the 30s and up till the 50s. That was a disruptive technology. Today, we haven't seen a major disruptive technology in aviation. Everything is reactive. We're trying to build on the platforms that already exist. But once something comes up, I'll give you an example, digital photography versus the film usage. That's what we talk about disruptive, and how will it affect the way people fly or the way people transport. The resource wars, we all, of course, are aware. The race to space has many aspects also. We see with the introduction of the private sector, the SpaceX company into the race to space, the technology is being pushed, and that will definitely benefit the aviation. And the environment is important because a lot of pressure is on the engine manufacturers to reduce emissions versus save on fuel. And if you want to save on fuel, then your emissions will rise. So there is a paradigm here that I will show you some of the stuff that other manufacturers are doing to go into zero emission airplane. And I mentioned here also the leadership, because today with the COVID-19, the leadership have been put to an unprecedented test on how to manage the airlines and the industry itself. And we saw a huge segregation of who managed to use the resources right to be able to get out of this in good shape, and who failed or tried to stay put and avoid getting into the mix of what happened after COVID, and that led to major disaster in some of the airlines and the companies. Few points that also some of our friends are looking at. 2030 and beyond, if we want to discuss the future, will or can the airlines continue to stay autonomous as independent companies, or will they integrate into other businesses, or maybe aviation could or would become just a commodity supplier? Look at it from Uber point of view. You don't care what type of car is coming to pick you up, or who's the driver, as long as he has a good rating. So could the airline become something like this? You get into a website and you choose to go from point A to B to C, and then they assign you to an aircraft. You don't care if it's an Emirates or Etihad or British Airways. You just get on a plane, it takes you somewhere. There is talk about the air cruise, the slow travel, and the social travel. Basically, people would love to go on a cruise ship. You can go on a cruise aircraft that will go up in the stratosphere, close to the stratosphere, and then stop somewhere and then go somewhere else, and you spend a week or 10 days as a vacation. That, of course, will put pressure on the technology, and how will the technology develop. We have seen also revenue streams vary. The airports now are making money. Airlines were not making money. So a non-aeronautical could become a revenue stream that could help the aviation industry. Airports also of the future, a lot of people are looking at that. And then cargo. We all saw at the epidemic, the cargo became very important to transport vaccine and goods quickly between countries of manufacturing like China and Europe into Middle East, Africa, and South America. So cargo companies have now to change, because the way cargo is transported today has been tested and was put to a very harsh test for the people who did not own cargo capability or did not have a solution for the cargo. And the last question that we talked about earlier is the disruption. Will the technology disrupt the industry? Will something new happen that we can, that will change the way we operate in aviation. So the aviation started by us learning to fly. Today, everybody wants to fly faster, wants to fly further. So what are the innovations that everybody talks about? There is talk about going to single pilot, assisted by a second pilot somewhere on the ground, and even further to unmanned aircrafts completely managed from Earth. Going to higher speeds and higher altitudes. We are talking about the hypersonic airplane that is being tested nowadays at a Mach 5 times the speed of sound. Go from Dubai to London in 2 hours or 1.5 hours, to New York in 3 or 4 hours. The introduction of Airbus introducing the hydrogen-powered airplanes. The introduction of electrical with the UAV. Very soon we will see storms of drones that are monitoring electric wires or military installations or trying to control fires. This is being worked. It's not really a science fiction. Very soon you will see that happening. Furthermore, Earth-to-Earth rocket, we talked about SpaceX. They are trying to think, I can go from here to China via a rocket that will go up and then it will split and will land you in China in no time. We talked, we all heard about the hyperloops, how to transport people really fast on the ground. So the aviation also needs to think in that domain. We talked about the emissions and the cargo solutions earlier. What are the enablers? And I think my colleagues here are going to talk a little bit about it. The material is very important. The coming up with ultralight material that allows people to be transported fast, efficient, and with lower emission. The current material that we carry is heavy and requires a tremendous amount of thrust to move it from one place to another. Alternative fuels, we talked about the resource wars. Who would come up with fuels that will be able to replace the fossil fuels that are being used today? The introduction, of course, of artificial intelligence and robotics in controlling the airspace. How do we come up with new propulsion? You know, Pratt & Whitney, GE, Rolls-Royce, everyone is testing new propulsion systems that are going to revolutionize the industry to be able to support those great ideas that we talked about. Training and the security technology are very crucial in preparing people for what's going to happen. The last one is now the introduction of the healthcare factor into the industry. As we go from one place to another, and with the introduction of the vaccination and the idea of trying to control who travels, who goes where, I think we need also a new look from a healthcare perspective on how to support the industry from a healthcare solution. Here I will show you quickly few of the ideas. Those airplanes, the bottom one in particular was shown at the Paris Air Show. It is actually there. It's an electrical plane that can fly between cities or even within a city. It can carry up to 6 people. It's fully electrical with batteries. The top one is another idea that works on a 14 passenger, all electrical or hybrid at one point. To the right, we have basically the NASA design, which is basically called the double bubble. It's 2 airplanes that are welded together, and underneath the pie at the tail, you could see 3 engines that could be either burning alternative fuel, could be hybrid electric, so starting as a jet engine, then going to be transported into electricity, making electricity and going on electricity. It's a actual model. It's designed by NASA with collaboration with MIT and few other companies working with them. But this is the hypersonic airplane. Again, you know, it's based on conventional technology, but modified the aerodynamics to be able to go to the stratosphere at 45,000 feet or even higher and go at 5 Mach. So it is actual idea also, and I think a prototype has started flying recently. Here is what Boeing is coming up with, the sugar vault design concept, basically ultra long wingspan supported by trusses, as you can see here, has 2 engines. They are harbor turbofans, so basically they start with conventional fuel and then they convert to electric motors and they fly with it. Of course, that will require modification of the airports because that wing is huge and no airport can accommodate it. So either they'll be breaking the wind at the middle like they did with the new 777 that is coming out next year, or basically it will require a special terminal to be able to park a plane of that size. So everybody's still going bigger airplanes, bigger wingspan, trying to go further into, but of course, eco-friendly with almost very, very little emission compared to the existing. This is the Airbus Zero-E. It is basically hydrogen-powered aircraft. You see the multiple engines in the back. And basically supported, so it's burning basically hydrogen. So the exhaust is water. And then you have hydrogen fuel cells that are powering the aircraft. A prototype of this aircraft has already flown. So it is a proven concept, let's say, but it's out there and it's flying. So we see that everybody's looking forward to come up with new ideas and investing heavily. This is big investment from the manufacturers to try to comply with the requirements of the governments and the pressure that they have. I wanted briefly at the end to look at COVID-19 because basically COVID came when everybody was doing what we were talking about earlier and put a stop to all of this. The trajectory has been disrupted. The idea of having mega structure like the A380 or the 747 basically failed. Most of the A380s and the 747 were the first to be parked and taken out of the fleet because of the cost of operation. And then the cargo demand became very, very high, which of course put pressure on converting these airplanes to become cargo. So the faster you can convert the 747, and I hear that also Airbus is working on a solution to convert the A380 to become a cargo airplane. So some airlines, as I said earlier, went seeking help from the government. Some airlines tried to adjust their model, which were very successful. And the LCC model, which is basically based upon, at least in Europe, on leisure travel, tourism, failed because no one is flying around. So hopefully Easter will be a good test when some countries are opening up for some leisure travel. And of course, China and Asia had placed huge orders on the airline, which of course are being revised, and the fleets are grounded everywhere. The 65 million people work in this industry. Now we need to find a solution, how we redeploy them. We saw clearly, and that's a big subject, how the CEO behaved, the ones that understood the crisis and redeployed their fleet or their technology, succeeded. The rest went to the government asking for handout. Cargo is, as I said, is going to be a big player in the few years to come, and we will see special designs for cargo airplane. The Chinese effect, of course, how they managed to handle the pandemic and go back to flying is an example for everybody to look at and learn from. And we expect in the industry by 2024, we go back to the 2019. So we still have 2 more years of restricted travel. The way we go through airports today is not sustainable because of the COVID. So they need to redesign the airports and consider how the vaccine will affect to be able to go back to the trajectory we discussed early on. So that's, I think that's all what I had. And I'm open for question if anybody has any, or at the end of the session, would be my pleasure.
Thank you very much, Mr. Isam. We'll be taking the questions at the end of the session. Next up, we have Mr. Pavel. He is the head of R&D in NNTC. He has extensive experience in hardware systems design, including embedded devices, motor control systems, CNC machines, and the recent development of specialized drones for light shows. Today, he'll be talking about a modern way to fly. Mr. Pavel, you have the mic.
Thank you very much, Hamda. Thanks everyone for joining today, and I'm really glad to talk here today. So while Mr. Isam was speaking about the big aviation with a lot of history and roots, I'm going to speak a little bit of a smaller brother, which actually emerged quite recently with an introduction of several, say, new technologies which enabled drones to be able to fly. So let's take a look at basically what is happening today. If we look at the future of transportation, I just Googled several ideas today, and that's what the screens which I came up with the search, right? What will be in the future for transport? A lot of ideas is about traveling into the cities, about delivery, about the personal ways to move, about traveling between the cities, for example, with a hyperloop, and so on. But still, there is one dream of the humanity which actually stays alive probably for the thousands of years, and still with the drone technologies, it's actually become even bigger now. Everyone wants to fly, and everyone wants to fly actually short distances even inside of the cities. The interesting thing here that if you look at these pictures now, which are on the slide, these are all about what the general public today call drones. And if we look into the history, then let's ask the major question, what the drone is. In fact, the drone as a term appeared in the beginning of 20th century, when the first artificial targets for anti-aircraft weapons were designed. And that's what was coined as called as a drone at that time. Today, if we think about drones, it's called UAV, UAS, RPAS, and so on. These are abbreviations which defines basically unmanned flying machines. But again, in a general understanding, when we say the word drone, most of the people would think about multicopters. And if you look at the photo, which is old one on the left upper corner, that the first quadcopter was ever constructed by the humanity, and that was done in the beginning of 20th century. The question is why it didn't fly. It actually flew somehow, but it was proven that this design is actually not practical. And if you look at the bottom left corner, there is a modern industrial drone made by the market leader, which is actually widespread today and used in many, many industrial applications. Like Mr. Isam mentioned, there are a lot of applications, for example, for the inspection of a power lines. And that's been happening today. So what made it possible? And here we really need to speak about the technology, right? So that was the materials, batteries, it was microelectronics, and it was motor technologies. That's what changed since the beginning of 20th century to the beginning of 21st. That's basically several basic technologies which made what we call drones or multicopters possible. But the question is, why they're so popular? And that's an interesting thing to discuss and to actually talk about. If you look at the picture here, what do you really see? Do you see the aviation engineer flying this thing, or maybe the test pilot? Not really, and that's what technology disruption did to this industry. Most of the multicopters, quadcopters, hexacopters, or whatever copters are there today on this market are being designed usually by programmers, by the IT guys who are very good at writing the codes and making the math, but they are not really excellent at aircraft engineering side, which is really, really very specific and complicated science. So what are the pros of the multicopters? They are really easy to build and maintain until the certain size of it. They are easy to fly and operate. And this is an interesting misperception by the public, because what we see as a consumers, we go to the shop buying a drone, usually quadcopter with a remote control, and once we take the remote control, it's really, really easy to fly. But it's not so from the aerodynamic point of view, because originally the multicopters are not really stable. So it's a software which and microelectronics which makes them easy to fly. They are usually autonomous, so most of these drones would be equipped with autopilots and some sort of intelligence, including, say, artificial intelligence, which will help them to detect obstacles, which will help them to navigate over the terrain, and so on. One of the biggest features of any multicopter, it can take off and land vertically, and it can hover. That's what's very important for the cities and for the small scale users, right, who cannot build a runway in their backyard. So that's basically the positive side of that. But you know, all the conveniences and all the simplicity is always comes at certain cost. So if we look on the other side, we see really low energy efficiency. It's probably the lowest of all flying machines except probably rockets. Basically, because if you look at quadcopter or hexacopter or any kind of these multicopter machines, it's basically the brick with batteries with attached propellers which propel it up. It doesn't fly too fast. Typically, even in the best commercial machines, the speed will be limited by 60 to 70 kilometers per hour. It doesn't really carry a lot, and that's another limitation which really limit their commercial use, except the industrial inspections today. And one interesting fact, and that's really not very well known, it can go up fast, but it cannot land fast. It's because this is aerodynamic limitation which they have. The pitch of the propellers doesn't change, so the propellers, when the drone with such quadcopter will descend, the propellers will actually limit the speed of descent because they just freely rotate, and they cannot they prevent it from falling down too quickly. And an interesting thing, it's not really reliable as many can think. If you look at the simplicity of the mechanics of this device, it's basically nothing else as 4 or 6 or 8 or more motors with the propellers, nothing else. But at the same time, the reliability of them is completely on the software side and on the microelectronics side, which has to be specifically designed like in an actual real aircraft with multiple degrees of backups and automation in order to be reliable enough to even fly above humans. And that's not speaking about transporting the humans, which is completely different story. So if we look at the transport, say cargo or the flying taxis, what should be the properties of these machines to make them, say, commercially and practically successful? So we still think about vertical takeoff and landing because majority of these operations are taken care in the cities. So we are not going to build runways on the roof of every building for the traditional airplanes. They still need to hover, especially if it's a delivery applications where you need to hover above certain point and just deliver the cargo down there with a winch or some sort of a containers. And that's what's been tested in the many parts of the world today by the commercial companies. How, for example, Amazon or say Google, they all test this kind of things to deliver the goods. And moreover, there are several commercial applications which happen. There are actually 2 very interesting projects which happen in the world that are commercially successful to deliver, say, medicines in the remote areas. And this hovering capabilities was really required there. They have to be autonomous, so the intelligence and all the software pieces still must be there, because we are going to tell the drone the point to fly, we probably will tell the route to fly, but the certain degree of intelligence should be still on board in order to say fly inside of the cities, because we can have another air traffic in, we can have different obstacles which we don't know from the control perspective and so on. And one next point, which actually very important, they must become much more energy efficient in order to be practical. Because if we look, even the best multicopter today can stay in the air, say maybe about an hour without the actual cargo to be carried. If we put a cargo, we will be limiting this time frame by 20 to 30 minutes. And then obviously we need either to replace the batteries or we need to charge them, and charging the batteries is minimum another 30 minutes. So that's what really prevents these things from the commercial success. And the second thing, and the last, and what I mentioned in the previous slide, we still need to be safe, reliable, and proven by time with the safety records, because once we are trying to fly inside of the cities and above people, we are taking the risks, right? And that's what must make these machines really safe. From the organizational perspective, there are still a long way to go, because if we look at the commercial aviation world, the regulations for the commercial aviation started to appear probably around 100 years ago. And since then, there was a huge experience which was actually accounted into the modern aviation standards, regulation, testing practices, flying practices, training, and so on, which makes the modern aviation really, really safe. So we need to bring probably the same ideas to its smaller and new innovative brother, which is the drone world. So basically there should be lots of efforts to be invested into the clear and detailed regulations in terms of how we operate them. We still lack a big piece, which is integrated, which is an integration with air traffic and drone traffic management, because it doesn't exist today. And imagine tomorrow if we have thousands of drones flying in the airspace of the city, obviously we are going to face a lot of issues like collisions and other not really pleasant things. And that's something which has to be taken into account. Where the world is today in terms of that technology is basically at the stage of designing more efficient flying machines. And if you look at the traditional aviation which is there, then the most efficient flying machine which can and practical machine which can take off vertically and land and hover is basically traditional helicopter. And there are several types of them exist, and the most efficient of them is actually coaxial helicopter. And that's what we actually wanted to show today with our partners who develops, say, a modern UAV for the cargo, is basically the coaxial helicopter drone, which does the job in the most efficient way in a smaller scale than traditional helicopter. If you look at this particular slide, you will see that what is being flying today as an experimental aircraft, and there were several of them already produced. This is the first commercial, not military, coaxial helicopter drone which can carry up to 100 kilograms. And it's if you look at this, what the developers and engineers tried to build in here is they were taking the best from the traditional aviation world and bringing it to the smaller scale in order to make this machine efficient, safe, and very capable in terms of the transport and the goods. And that's what is reflected in the technical characteristics of this machine. Is basically it can fly up to 6 hours, it flies at least twice faster than multicopter, and it has huge practical range, which makes it enables it to be used in such traditional areas like delivering the cargo, small cargo, to oil rigs in the sea, or delivering emergency supplies to the remote areas of the countries or outside of the cities. So that's say would be the first step, right? At the same time, we as a company, we also developed the software which operated machines. And if you look at the screen here, what you will see is basically an integrated mission planning software, which currently has immersive 3D flight planning, where we can define the flight routes for any flying machine in a convenient view for the operator. We do integrate with air traffic management systems, where we feed the information into the system, and we can give the information about the drone operations in the area to the traditional aviation authorities, in order to make sure they aware of what's going on at the lower heights. We provide ADS-B support, where we really know the location of other aircraft, and it's capable to control multiple UAVs, provide real-time video streaming, telemetry, and so on. And it supports multiple autopilots. That's, say, the small first technical steps in order to enable this industry to become more efficient and better and more commercially successful. And hopefully we'll see more development from the competition, from the authorities, and from all engineers all around the world to support this industry more and more, and get to the dreams of the humanity, when you can call Uber style drone, which will take your package from your balcony and deliver it to your business partner on the other side of the city in, say, 20 minutes, without driving it through the whole city of the post. That's basically everything I wanted to tell you today. Feel free to ask questions, and yeah, reach us out if you find it's interesting to discuss.
Thank you very much, Mr. Pavel. Very interesting presentation. Next up, we will have Mr. Gautam, the Commercial Director of DGWORLD. He is a global business leader with proven success in delivering profitable growth and creating value for shareholders. He has 20 years of experience in the business development and advertising field in the automation and robotics industry.
Good afternoon, everyone, and thanks for inviting me over to make this presentation. While we've seen such amazing aircrafts looking more and more beautiful, and hopefully they're more affordable as well, and drones that can carry 100 kgs and move 500 kilometers, it's absolutely amazing stuff. And this is just probably the beginning, and I'm sure there's going to be lots more stuff that will be coming in as well. While I will not concentrate on any particular area of either the air or drones, I'm just going to talk about, the smart transportation in general, and the kind of impact that it has on our economies across the world. So, and I will try and go as fast as I can. Okay, one of the biggest concerns that we have today is that we have a growing world population. Today it's about 7.7 billion, and they say by about 2050 it'll probably move to about 10 billion. And this is when AI, digitalization, next generation technologies will play a key role in basically driving transitions in supply chains to have more efficiency, more productivity, because we now need smart, intelligent transportation networks, infrastructure to sustain this increasing population. I mean, you see the roads today are absolutely jam-packed with currently, basically the entire infrastructure will need to change. The thinking of how to transport people and goods from one place to the other is going to change. And yes, I mean, if you look at the internet today, you go through Google, you're going to find hundreds of ideas that are there. Pavel showed us about 6 or 7 of them. I will show you a few, and these are just a very few number that we are showing. I mean, you can actually get into the YouTube channel and see how people have made videos about what cities are going to look like. Even if you go to the Dubai frame, which is there, and before you exit, it shows you what Dubai is going to look like in 2050. It's basically scenes from Back to the Future, where you'll have aircrafts flying, cars flying, airports, these pods moving around, hyperloops, and a lot of that. So it's all dreams right now, but I'm sure they're going to become realities extremely soon. There are some considerations that we look at when we look at the future of transportation is basically smart sources of energy. Today, we are using fossil fuels like petrol, diesel, coal. These are changing now. People have started using a lot. It was shared that a lot of hydrogen gas and biofuel, solar, wind, a lot of that is going to be used to make it more cleaner air for all of us to live in. Infrastructure, both physical and digital. When we've come up with all these new innovations and smart technologies, we need to build these structures, whether they're physically built into the various parts of the city and digitally done so that this connectivity can work well. So a lot of that. Then we've got electrification and shared micromobility. This basically has already started. We've got electrical vehicles now. We've got electrical cars. We've got electrical trucks, and we've got electrical buses, which are there in the world in various parts. So a lot of that. Then we've got the LEVs, which is the light electrical vehicles, which come into shared micromobility, which you've probably seen. In a lot of places, even within the UAE, you've got these e-scooters which are there. You've got e-bikes which are there. So this is basically, these are LEVs that are shared between multiple users. So then you've got last mile technology, transportation, which is there. So a lot of that. And then you've got autonomy, which is basically self-driving cars. I think a lot of cars today are getting equipped with a lot of self-driving features into it, but there are some limitations that we have in terms of infrastructure in place, insurance in place. We have to get all of that ready. But having said that, companies are, coming up with autonomous solutions in large numbers that are coming in with that. Basically, when you look at smart transportation, if people and goods are well connected, it will generate new opportunities. It will enhance economic growth of any country. It will increase the employment. It will become easy for people to commute from their homes to offices, from their cities to another city, from cities to other countries. You've seen with the way aircrafts are being designed for the future, where you can travel between London and Dubai in 2 hours, and London and Dubai and New York in 4 hours. So it's going to make it easy for people to travel around the place. So that's going to help. Then investments in smart cities that are going to be made, markets that are going to be opening up. I mean, local produce will get now access to global markets, global consumption, which is there. You see, in any developed economy, including ours, transportation accounts for almost 8 to 12% of the GDP of that country. Then we've got 3 factors that enhance the economy, taking it further on how it would work. One is geographical, the other is operational, and the third is enablement. When we look at geographical, smart transportation will allow easy access to raw material to move around the place, for labor to be moved around the place, for parts, for energy. This is going to increase productivity. Then connecting local products to the global economy of consumption, distribution, and production. It's going to be easy for something to be manufactured in Sharjah or Dubai or Al Ain or Abu Dhabi to be, reaching out to markets which are across the world. That's also going to bring in more revenue into the country, and it's going to help. Then we've got the operational. You see, we look at technology in transportation, time, efficiency, all of this will increase. You're going to get faster, frictionless, automated, personalized. When you travel on demand and increased economic growth, when you say travel on demand, it's like you will actually have apps that you can order your pod or your drone to carry you to places, or your automated vehicles that can take you from one place to the other. So a lot of that. I mean, you look at traffic congestion today is costing the world today almost about $21 billion a year, and this is going to help reduce that and increase revenues and economic conditions for the country. Then we've got enablement. The more roads, the smarter the roads, the more the means of transport is going to lower the cost of goods and service, which is going to directly increase economic growth. So there's basically going to have more with less. The next thing that we have, which I'll talk about, is you've heard of buzzwords today are Internet of Things, autonomous vehicles, self-driving vehicles, electric vehicles, a whole lot of that. So next, what we're talking about here is Internet of Vehicles. Connected vehicles will do for the automobile industry what literally smartphones have done for the phone industry. You can have everything on your fingertips. And today, all the new smart vehicles that are being made are being outfitted with vehicle to vehicle, vehicle to infrastructure communication technologies, so that every vehicle can know where the other vehicles are on the road. Basically, it's allowing our vehicles to exchange information both efficiently and, importantly, safely with one another and with the infrastructure. This basically enabling, say, real-time communication between vehicles, pedestrians, roads, parking lots, city infrastructure. So that's what the Internet of Vehicles is. That's a part of the Internet of Things of any smart city that is coming up. These are some of the ideas that I came up with after look. I mean, I didn't come up with. Sorry, I saw on Google and I selected these because they're a lot that is being talked about these days and looking more, in closer to reality than some of the others. We've got self-driving cars which are coming in. I think today a lot of these Tesla cars are already fitted with self-driving features, but then there is no connectivity. You can't just rely on a 4G connectivity to be traveling in ever-changing, dynamic, real-time situations. Then you've got flying cars and drones with vertical takeoff and landing transport. You've got driverless pods. What you see in videos, you can actually order a pod through an app. You can, come out of your office. You can decide what time you need to be somewhere. So the app will tell you to reach a particular position, a particular place. You need to leave at so-and-so time. It calculates a lot of that, the time, taking into account the traffic situation and a lot of that. These are fewer of the ideas. Then you've got the skylifter. So you take them out of the roads, up onto the sky. We've got the autonomous ships of the future, which are coming up. They say by 2030, you should have the first autonomous ship sailing in the seas. You've got the Skyway project, which already is a project that is being done at the Sharjah Research Technology and Innovation Park. That's also another game changer, and it'll be a proud moment for UAE when it's up and running, and something else that we can showcase to the world as well. You've got the super yachts where you've got air transport, rail, road. Here you have sea, and then you go under the sea as well. Now all of these are not just transportation. These are efficient, fast, using the renewable energy. A lot of that. There are concerns. It's all nice to know of all the new innovations and ideas that are coming up with. But there are some concerns. I wouldn't say there are disadvantages or cons or anything. There's just something that we can think about. I mean, will we stop walking and cycling and now start taking AVs to the gym and parks instead? Is that something that was going to be affecting our health? With the other most important thing, I mean, we talk about all these fancy cars and fancy ways of transportation. Who are they meant for? Are they only going to be for the elite and privileged, or are they going to create opportunities for those who are in the greatest need, which is the common man? Do we manage our current infrastructure smartly, or we start building new shiny stuff in cities to enable a lot of this smart transportation? And will the country invest in communication infrastructure to cater to the needs of the amount of real-time data that any autonomous vehicle will take? I mean, today we have roughly about 3 million cars on the UAE roads. For those 3 million cars, we today require 12 billion GB of data every day. If you dissect it further, you're looking at about 139,000 GB per second is what we require. So these are things that we've got to think about. With their concerns, they're not anything which is there, but I'm sure people are looking at everything when they come up with all of these. DGWORLD, we're basically UAE-based company. We are in two parallels that we work in. One is autonomous solutions, and the other is automation using robotics, which is today, robotics is now part and parcel of our lives. It's not just, it used to be largely in manufacturing sectors, particularly in automobile industries, but today it's moved into hospitality, F&B, medical in a big way. These are some of the solutions that we have. Go back one. Yeah, these are some of the solutions that we have developed and come up with some partners of ours who we've collaborated with. We've got last mile delivery, which is the electric vehicle, which you see on the top left. It's again, it's for food and goods. And like I said, it's last mile delivery. So in a lot of communities that you see where you have hundreds of bikers coming in to deliver food and stuff. So you can have these delivered to a particular point, and you have these last mile delivery vehicles that can actually take it inside to houses and establishments which are there. Then we've got the autonomous LEV, which is for schools and universities, which is the top right. We've got one of the schools that has actually taken one of our vehicles and looked at how they can train their students on autonomy and see how they can learn to program, learn to see what they can get as results out of when they move these vehicles around. We've got a taxi that we launched in 2018, and then we did a dry run in one of the areas in Dubai, and basically it was an 8 months R&D project that we worked with the Road and Transport Authority here in Dubai. And we wanted to learn how the car would react with the road conditions, with road markings, with pedestrians. We were trying to get as much data out of running these cars, which would help us in the future. We've recently tied up with Boston Dynamics as their agents for the Middle East and Africa. And Boston Dynamics has a lot of interesting products which are there. And one of the things that you see on there is basically something that they call Spot. Spot is largely, again, for deliveries, which is there in the construction industry, deliveries in other areas. It can be linked with, last mile deliveries, can work in tandem with them, and see how we take things forward from there. Then we've got our passenger transportation bus, which is there, smaller sized ones, which we have already converted and have ready tested and is a ready product, both in using fuel and using electrical. So that's something that also we have worked on. We've got electrical forklifts, regular forklifts, which are autonomous, which can move around within warehousing and factories to move things around. And last but not least, we've got, and this is really proud solution that we have come up with, not just for DGWORLD, but for the UAE as well. This is what you see on the left is the first autonomous truck in any seaport terminal in the world. You've heard of them. There have been trials which are going on across, but this is now a functional vehicle which is testing inside these terminals in large numbers. So all your shore-to-ship and ship-to-shore functions are now being handled with driverless vehicles. And these are not vehicles that they have bought anew. These are vehicles that are existing, and we've converted them to become driverless. Basically, in a nutshell, in our autonomous solutions, what we have is a combination of hardware. Here again, we've teamed up with the leading providers of hardware across, being Velodyne, and we have Danfoss, and we are working with Region Corporation for all the connectivity, and our in-house developed fleet management software that is basically used in conversion of these manually driven vehicles to become driverless vehicles, to be able to communicate truck to truck, truck to the control terminal operating software, and to be used in every way that a vehicle is now being used. There is so many other advantages that are there when you get with this, with kind of savings that you get out of using autonomous trucks is tremendous. And today we've reached level 4 and 5 of autonomy. But it's just that when the country is ready to roll out our autonomous vehicles, we are ready as well. So we don't want to be left behind. Thankfully, we've had this project with DGWORLD, which has allowed us to spend years in doing a lot of R&D, and they have been with us at our side and helped us in every way possible. This is a short video of what we've been doing in DGWORLD. And with this video, I would, after you see it, just to say that we are ready to support UAE's smart vision in the transportation sector. And hopefully a lot of our dreams will become realities.
Thank you very much, Mr. Gautam. I think there's a problem with the video because we can't hear. So we'll be moving to the questions now.
Okay.
So this one is, I think, for Mr. Isam. Can aerospace manufacturers and airlines guarantee that test limits of human attention won't compromise the passenger safety during the autonomous rides, basically?
Very good question. Thank you. Just let me tell you that last year, the US Navy has tested successfully with one of the manufacturers a fully deployed airplane that took off unmanned from a carrier in the middle of the ocean, did the mission and came back and landed safely. So the technology is definitely there. The unmanned aircraft, and Mr. Pavel has given us a very good insight into the technology, is quite capable of launching a mission and landing it. And basically today on a 787, for example, or an A350, basically you can, after takeoff, you can switch off the airplane into automatic mode, and it will fly and land automatically without any intervention from the pilot or the co-pilot, apart from doing the communication. So the answer is yes, safety is a concern, but it is within the realm of the technology available today. And I think they will test it first with a one driver only, and then eliminating the drivers in cargo flights, and then we'll see how it goes. But yes, the technology is there. They can get, I think the safety is concern is valid, but I think the technology is available to mitigate it.
Thank you. The next question, I think, is for Mr. Pavel. How will the drones help in underdeveloped countries, for example, in Africa?
It's a very interesting question, in fact. I mean, if you look at the existing example, and one of them I actually mentioned, but it didn't name the country, there is a project which is a commercially successful project now, and it's not only commercially successful, it's also socially successful project, which is happening in Africa today. It's a delivery of the medicines to the remote areas. Imagine you in Africa, the countries in many cases have no road infrastructure, and some places are not really accessible, and aviation is not really available there because of a tremendous cost in comparison with the wealth of these countries. And that's where the drones can come and really help a lot, because the cost of operating a drone is significantly less, actually 1,000 times less than the cost of operating a real aircraft. So that's how it can happen. The question which is, to my mind, is still open is, say, how do we find such sweet spots? How do we find such areas where this can be supported by the economy and not only by the requirement? Because there are a lot of things which obviously are required by the underdeveloped societies, right? But they do have the requirements because there is no economy which support that. It's not about the technology. It's not about the capability of the drones or cars or aircraft. It's more about the economy which stands behind it. And if there is a real economy which can pay for that somehow, then if we find such use case, then it really starts helping. That's what is happening.
Thank you. So this next question is for Mr. Gautam. What are the common barriers to accessibility facing the transport operators around the globe?
I think transport operators around the globe, the barriers that they are facing is a lot of compromise to safety. The whole idea of getting into people wanting to get into smart transportation is to avoid a lot of accidents that happen across the world. And it is a shocking number when you actually look at the number of accidents that happen, where millions and millions of people are dying every year because of that. So there is, the road conditions are not good enough. The infrastructure is not so much there in, of course, some of the larger, well-developed economies, I don't think they have much issues. But yes, accidents, safety is priority for any transport operator which is there. So you've got some of these barriers which are there, but I don't think there will be barriers for too long, because the way everything is evolving, and you're looking at some of the ideas that were presented earlier. Every year there are newer things that are coming up, and there is a think tank who is sitting and actually looking at seeing how things can be managed better. So I see what barriers are there now would probably not be there in a year or 2 years' time. So that's how I see it.
Thank you. I think this will be it. This will be the end of our session. Thank you to all the speakers, Mr. Isam, Mr. Pavel, and Mr. Gautam. It was a pleasure having you today during this webinar. We learned a lot. And thank you for everyone who's joining us.
Thank you for having us.
Pleasure.
Thank you. Thank you.